Mory,
Hey,
thanks
Vik.
for being here.
Thank you.
And I'm sure that you're super excited to see the solution here in Rakuten booth. And I just want to understand more about the solution and how Supermicro is fitting into this. Because as you know, Supermicro has the entire spectrum of hardware based on every generation of Intel product family. And but at the same time, I mean, most of it is actually geared for data center. So can you tell us, like, how is it different from what we are actually using in a data center?
Sure. So I think first of all, we are aware of the data center architectures. It's require a high density of computing, and then also because they have a bigger space, so we are able to put lots of the computing power into it. But when we're looking at the telco space, especially for the radio access network, there are also lots of the possibility to be virtualized, and also could be becoming more open interface. That's what we call the open RAN. Because this open RAN, we have a choice using a different hardware to do the similar job at the field for the radio access network. When we're moving the data center technology to the edge, it's something requirement changed. No longer stay in the like data center environment. And the first big challenge is the cabinet size.
I see.
And then the second thing also, things become front access because not enough space, so it's be easy maintenance. So then the data center wise, you have a cold zone and hot zone. But in the cabinet size, there's no zone, everything's front. So we have to change a little bit there.
I see. So I see here, like it says something about a cell side DU server. So what exactly does cell side mean?
Yes, so most of the user, when they start to use the mobile device, they call the user equipment with UE. And this user equipment, when they start to have the phone functions, they will find out the radio unit first. The radio unit will help to transfer this phone calls through the Ethernet port into the distributed unit. That's the first part called distributed is DU, but it's closer to the cell side router area. So this calls the cell side DU server.
So, I mean, I see this server. I mean, it's a 1U system, and it's fitting all the bill. Then, why do I need a 2U system for the same thing?
Yeah, it's lots of questions. Similar in this way, and the customers want to know if the density is higher, it doesn't make sense. Go to the 2U form factors and still have a single socket only.
Right.
It's also related to deployment at the field. At this situation right now, because it's the cabinet getting smaller, there's a certain requirement, it's got to be smaller than 300 millimeters.
I see.
So this possibility.
So you're trying to make it backward compatible in an existing chassis that's already there, existing rack that's there already.
Yes. So we make it more easily for them to go into the existing cabinet,
I see.
and then are able to insert into it. But because there's a fixed requirement there, so we have to make this device more friendly to the cabinet. However, the customer also have a new cabinet. They're able to give us more space. Then we can give them the same technology, become the density more higher.
I see. And I see, like, suddenly changing to like a data center DU, right?
Yeah.
So, I mean, I understand on the cell side, but what exactly the data center side and where exactly is data center going to be?
Well, first of all, in this telco cloud, to Rakuten Symphony to actually bring the communication all the way from the user equipment back to the data center.
I see.
But there are many data traveling, we need to fill out different sites. So we are aware of the UE to the radio units, then we'll connect it to the distributed unit, central unit, and back to the core network, and then we're into the cloud to the data center. In this journey here, the bandwidth, the environment all changed. So that's the reason why you can recognize we have systems, have a front access. But then sooner or later, when they go into the data center wise, we will need to align with the data center settings. But we can support both. So that's the beauty. We can using the similar computing platform and let the Rakuten Symphony software easily to traveling between different hardware platforms from Supermicro.
I see. So that kind of explains, why this all of a sudden I see like a data center from a CU or core, right? So it's kind of moving the data from all the way to from the edge into the core of the data center.
Correct.
I see. And I also see like some of these things are multi-node. Why do you need a multi-node system?
Yeah. In certain areas, the operators and also the environments want to have a redundancy and also want to support more unit. But some cabinet, if they only have a limited unit, then the more computing power delivered within the same form factor will give them more flexibility to do other services.
I see.
So that's the reason why we give them the 2U, 3-node. We call them this product as a Super H from Supermicro. It's allow you still to do the similar job in the 1U form factor, but still can able to expand to a different accelerator card.
I see. So I do also see that these are single socket Sapphire Rapids. So effectively means that is the number of cores coming from the Intel processor is increasing. That is actually having any impact on this one?
A little bit, but the situation is getting more valuable. When the core count got impact, for sure you have more features into the CPU.
I see.
And then previously, I think Intel have a Safari Rapid SP launched. But at that time, the CPU itself, they don't build in the accelerator like the VRAM boost function. But this time, with the coming solution, they call the Safari Rapid Xeon EE. This edge enhanced allow them to have more feature into the same CPU. And at this moment, you are able to deliver the same function in a smaller footprint.
I see.
So the smaller form factor in this way, they actually can do more job in the 2U form factors.
I see. So you're basically gonna free up some of the I/O expansion and improve the air cooling and all that. I mean, which is in a way somewhat relevant for this kind of let's say deployments where environmental
Correct.
Situation is not exactly friendly, right?
Yes.
I see. So that is it what it is basically the EE? Is the edge enhanced?
Yes. So you can recognize the Safari Rapid have a scalable processor, naming the 4th generation from Intel. But this coming version will be called Edge Enhanced.
I see.
And the Edge Enhanced could be many purpose, but this is a special booster inside. It's called the VRAM Boost. And the reason is that we can take a look here. If I pull out this one, you can recognize there's an accelerator card here.
I see.
And then with this accelerator card, they actually can do inside this kind of a design and also stay in the original 1U. We have a different expansion slot. But when we have a chance to bring this accelerator into the Xeon EE, then it's allow us to release the one more slot, which is more networking.
Does it actually reduce the power for the system in this case?
Right, actually, yes. So then because it's combining into it, not just save the material of the cards and also save the cost and also save the energies as well. Yes.
I see. And another thing I was also seeing is as I start looking from top to bottom, I see more amount of storage in this.
Yeah.
So suddenly, where is the need for the storage?
Yes, when we were handling the DU and the CU, most of the traffic we have handled is through this telecom Open RAN interface. But when getting closer and closer to the central unit and the core network, those data will be stored for exchange the information inside the telco network. But those jobs doesn't have to be done in the DU side. So you can recognize the DU side. You rarely can see the storage device here. But when you're going all the way back to the core network, it will require certain amounts, but doesn't like the streaming we have in the data center. So that's why we're allowed to distribute certain storage nodes into the SLAT.
I see.
Yeah.
I see. And I do also hear about the NEPS compliance. In some of your presentations. So any of these systems is NEPS compliant?
Yes. So for the systems have to closer to the edge in the telco environment.
I see.
Certain countries require the NEPS. So Supermicro do invest on this, not just on the Safari Rapid generation. We actually also invest previously on the Ice Lake as well. And you can recognize these machines, it have to be front access at the field. So they will require lots of NEPS compliance.
I see.
So we do have that version invested.
What about for European markets?
Yeah, that's called the ETSI.
I see.
So this one also required certain standards, and then we will also invest it for the customers.
I see. And I see the connectors are a bit different, some of these things. I mean, do we support both DC and AC power supplies here?
Yes. So we have customers in the different countries, different environment and different cabinets. Certain areas, they have a very clean power like the DC, but they also have some challenge. They also have an AC only version in their central office environment for the telco space. So we do have an AC power and DC power, both for the front access version. And the customers actually can easily stay with the same hardware for their software. And then computing, because based on the mobile software as a service from Rakuten Symphony, they should give us a good guidance. The customer, they prefer DC, we give them DC version.
I see.
But when we need to switch to AC version, we didn't change everything. We can continue to stay the same form factor.
Great. So we have basically the solutions based on Intel previous generation, which is the 3rd generation Intel Xeon, as well as the 4th generation Intel Xeon. Of course, it's called the Sapphire Rapids before launch.
Yeah.
And we have platforms ready for that, and looks like it's fully validated and stays here, right?
Yes.
I see. So is there anything else that you can mention that actually useful for us? I mean, in terms of how this overall flow is, and what work that you have done with Rakuten to make sure that this is available for all the customers?
Yes, I think Open RAN it's very popular word in the past few years, but make this possible is very challenging. And Rakuten Symphony gave the Supermicro a very good chance to understand in the telco world, we cannot just move the data center and throw to the field.
I see.
And then there are certain parts need to be handled. but we got a good guidance. We understand it's got to be front access, got to be require lots of the environment challenged. Once we fix that part first, there are lots of effort behind the hardware.
I see.
Before jumping to the software first, actually we need to make sure our BIOS firmware, everything will be friendly for the automation orchestrations.
So basically what you're saying is that we got the feedback and guidance from Rakuten in terms of what are the different things required in a telco environment.
Correct.
And we had to go and make these hardware customizations
Yes.
to ensure that it fits into the requirements and co-develop in a way, is it?
Correct. So that's why I think a simplify, not just from the software side, simplify the hardware structures will help this open RAN concept run faster, become more profitable. Supermicro invests about using the building block solution, allow our data center architectures easily integrate into the telco environments. And because of this, I think both company and also the industry will get the benefit from it.
I see.
And then we will continue to invest this road because Open RAN not just bring the benefit to the end user, because your communication cost could be less, but from the hardware perspective, we try to make sure this will also can reduce, become a more light-loaded infrastructures for telco environments.
Thanks, Mory. It's been extremely informative. And the good thing what I learned from this is the customization and optimization that we are doing through building blocks will actually help keep, not just keeping the IT green and from edge to core, wherever it is, I think it's something that we can help our customers with. It's fantastic. Thank you.
Thank you, Vik.